Okay, hello everybody. How you doing? Okay, how we doing? Yeah, okay. Beautiful weather outside, like 70 something degrees Fahrenheit. We're enjoying it, right? So a couple of things. We have an exam on Friday. It's here, and we can bring a couple of sheets of notes, handwritten notes, anything you want on them as well. Any questions about that? Okay. Yes. Yes, I have them right here. Yeah, they're right here. Or during, right? Once we get into the problem-solving stage of the course. Yes. If anyone needs to pick up their previous exam, we have them. And yeah, we have office hours today after class back on Bush, and we also have office hours on Thursday at 4:45 to 5:30. Okay, both on Zoom and in the office. Yes.
I think you touched this in the group meeting, but can you go over the content, like which sessions are covered by this upcoming exam?
Sure. So we should be covering essentially back, well, let's see, what's the best way to do this? So we should be covering from about session 11, okay, through the last session, 19. Okay, and free body diagrams didn't go away, right? So a lot of the stuff we covered for the first exam is going to be relevant to this exam as well. And there are prior exams, 2015, 16, 20, and fall of 2022 as well that you might want to take a look at. All right. I hope, okay, that this exam goes better, all right, than the last one, all right? And so I'm going to try to do my part to facilitate that. So please study, all right, so that we're in good shape, okay? Good. All right, so what are we talking about today? Yes, you may think, we all think, well, this topic is not on the exam. Nonetheless, it is more circle, I don't know, part 3 or 4 or whatever, right? It's actually, we're calling this absolute maximum shear stress on its own. But the basic idea, okay, for today is if we have, you know, some element with some state of stress on it, and we can draw, I don't know, I'm not going to draw them all, okay, but I should not draw that one either because that's the wrong way. Where's the undo? Where is the undo? I forgot my keyboard today, so this is a little awkward. Do I not have an undo? There we go. Okay, like that. Now let's say we have some state of stress. And, you know, in tensor form, we would say this is sigma xy. Actually, we'll do it this way. Tau xy, tau xz, tau yx, sigma y, tau yz. This is going to be tau zx, tau zy, and sigma z, right? So we have some state of stress, and we know that it's symmetric. So that tau xz is equal to tau zx, tau xy is equal to tau yx. So we really have 6 components. Of stress, okay, that we're concerned with. And what we're saying is that we can get to some new orientation such that we only have principal stresses at some transformed, it's kind of redundant to say it this way, but orientation. Okay, and so we're going to have a sigma 1, a sigma 2, a sigma 3. And typically we describe sigma 1, sigma 2, and sigma 3 in descending order. Okay, so usually what happens is we say sigma 1 is greater than sigma 2 is greater than sigma 3. Okay, you don't always follow this rule, okay, because sometimes you'll have, like, for example, it's very common to, at least it's common for me to write that we have a sigma 1 greater than 0, a sigma 2 less than 0, and sigma 3 is equal to 0. Okay, like that's a common way to express your principal stresses. So once we have these three principal stresses, the goal is to figure out what the absolute maximum shear stress is, right? So once we have sigma 1, sigma 2, sigma 3, okay, we want to find the absolute maximum shear stress. Now, we've already got some experience figuring out the maximum in-plane shear stress, right? We've done these situations, for example, right? This is, you know, from our past, and I guess this would be like session 19. We've done problems where we say, okay, there is a nice tau sigma plot, and we are going to call 1 sigma 1, 1 sigma 2, and we draw a radius, or we draw a circle, okay, and then we can put a radius in there. And this is this point down here, right? That corresponds to the tau max in plane. Okay, so whatever sigma 1, whatever the axes are for sigma 1, sigma 2, right? That's how we would figure out the maximum shear stress in the plane we're operating. Okay, but as you'll see, okay, if let's say that we have this element, and it has, we'll call this sigma x, which is equal to sigma 1, all right, and we'll call this one sigma y, which is equal to sigma 2, okay, and we'll say that sigma 3, or sigma x, z, is equal to sigma 3 is equal to 0. Okay. So now we have an opportunity to kind of think a little bit. This would be an x direction, right? This is a y direction. To think about what happens if we rotate this element 90 degrees and we look at the state of planar stress in different planes, okay? So in this case, we have x, y, and then z coming out of the board, okay, coming out of the screen. If I want to look at another state of stress, and in this case, I'm gonna itch to the one that I know is the most concerning, okay, the one that's going to give me the absolute maximum shear stress. Does anyone know which plane that will be actually? Which plane is going to give me that? Is going to give me, if you've done a little bit of, you know, listening or reading ahead, which plane in this case is going to give you an element that is a planar element that's going to show you the maximum, absolute maximum shear stress? Yes? So deep? Yeah, it's the xz, right? So if we rotate, let's just say we rotate positive 90 degrees about the x-axis. Okay, so if we do that, what happens? that would give us, so let's say we rotate theta x equals 90 degrees, okay? If we do this, we're going to draw another element, and the x direction stays the same. Okay, this x is still x, right? So, and this is not even, how do you put this? We're not even doing the transformations right now. We're just looking at a different perspective, okay, for this. So x is still that direction. If I rotated positive 90 degrees, now I've got y coming out of this thing at me, right? Because I rotated the element. It's now y shooting in my face, coming out of the board. And then z is actually going downward, right? So z is now down here, okay? So what happens here? Well, if we look, like, you know, it's maybe limited in our perspective to just look at the paper and say that's a plane and that's the stress we're interested in, but that's what we're really doing right here. So when we look at, what color did I use? When we look at sigma x, it's still sigma x going to the right and left, okay, like we have there. And if we look at sigma y, that's actually coming out at us, all right? So we're like, oh, let's just kind of ignore that plane for a minute, okay? And then there's no sigma z, right? Sigma z was equal to 0, right? So we can say that sigma z is equal to 0, right? That's the sigma 3. Oops, I can't draw. Okay, so sigma 3 on our Moore's circle is going to be over here. Okay, and if we had just looked at this element, the xz element, all right, or a perspective in the xz plane, right, all we would see is sigma x, right? That's all we would see. All we would see is sigma 1. And we see sigma 3 is equal to 0. So what would the Moore circle look like in that case? The Moore circle would be like that, okay? Looks kind of like an Easter egg or something, all right? But anyway, it looks like an egg, right? It's supposed to be a circle. So in this case, when I look at that plane, what I see is that the absolute, or this, let's not even call it absolute yet, right? Just the maximum shear stress associated with that plane and that Moore circle is larger than what I had for the other one over here. Okay, so this now becomes, whoops, the absolute max, right? And if we looked, we didn't do it, but if we looked at the YZ plane, okay, what we would see is we have the sigma 2 and also we have sigma 3, right? And we would be drawing this circle inside. Okay, and that's going to have a smaller maximum shear stress than the absolute maximum shear stress that we see with the XZ plane, right? And so keeping track of sigma 1 being greater than pretty much all the other ones, okay, is important for drawing these circles. Now you could argue, all right, well, if it's more negative than the rest, you know, if I'm on the left side of the tau, the positive tau line, right? Then, you know, maybe I should make that one sigma 1. Yeah, that you could argue that, okay? Sometimes it's more about the magnitude. But just keep in mind that usually sigma 1 is, you know, the larger one. And when we look at absolute maximum shear stress, in many cases we're looking at sigma 1 divided by 2. Okay? But there's a case where it's not sigma 1 divided by 2, right? And you've seen that, and if you go through the slides, you see that, right? The other option, right? Well, actually, maybe I'll just say, you know, in this case, tau absolute max is equal to the radius, okay, of xz Moore circle, or you could just say it's going to be sigma 1 divided by 2. There's another case that you'll see in the notes that we're concerned about, And that is when you have sigma 1 greater than 0, say sigma 2 less than 0, and sigma 3 may be equal to 0, okay? In this case, right, if we draw, and then you get to the point where you don't even look at the planes, right? You're like, I don't care about the planes. I'm going to just look at what I've got here. I got a sigma 1 out here somewhere, maybe. I've got a sigma 2 out here. And we've got sigma 3 right here. Okay. So when I draw the more circles in this case, the one that's going to be most critical, that's going to give me the largest, is this one. Oh, I'm really not, okay, anyway, pretty bad, okay? That's the one that's the largest Morse circle, right? And so if I look at the absolute max, what is the radius there? What's the radius of that really poorly drawn circle? Yes, go ahead. Go ahead, Amir. Nah, I wouldn't call it an average here. Yes.
Sigma 1 plus sigma 2.
Okay. Yes. So sigma 2 is actually negative. All right. So you've got the right idea. So it's minus, right? So it actually becomes, so the tau absolute max in this case becomes sigma 1 minus. So it's kind of like the average, all right? Kind of, right? But that's the result, okay? So it's important to be able to draw the Morse circle pretty quickly and then be able to figure out what the absolute maximum shear stress is. And that's it. The first portion of this assignment is pretty much Python, okay? I mean, if you want, you can retype it all in MATLAB, go for it. Okay, but I just would suggest hit Control-Enter like twice, and it will spit out the answer in Python, all right? But choose your own. Okay, and that's looking at 3D, well, it's looking at pseudo 3D actually, states of stress, okay, and then telling you what the principal stresses are, okay? And once you have the principal stresses, okay, then we can figure out the absolute maximum shear stress. If that makes sense, right? That's what we said at the very beginning, is that we start from some general state of stress, we figure out what sigma 1, sigma 2, and sigma 3 are, and then we can figure out what the absolute maximum shear stress is. Okay? That's pretty much it. So go ahead, watch some videos, work on the problems. Trevor and I are here. We'll be walking around and be happy to chat. And for those who are looking for exam 1, we've got it. Okay?
Professor, do you have exam 2 by any chance?
No.
Yes, which one?
Huh?
When you make height like that, just, you know, we're like messing around. You're
When you said that we have to, like, there's stuff from exam 1 that we should do, like, do you think I should use my equation sheet from exam 1 and then just make another one for this exam?
Yeah, if it was good, yeah.
Okay.
It's because we're best. That's why you got to must pack.
And there aren't that many equations. There are a lot of procedures. I would maybe recommend some of these procedures.
3 days. 3 days of studying.
I mean, I'll just use this as a
And I would go off the notes.
Make sure you I did that for like an hour. Like this is our year going, that's crazy.
I'll be there in like
I'm sad.
Yeah, so that's
Yeah, he took my spot.
Vincent is now Matt.
Yes, and I'm now Vincent. Yeah.
Okay.
I don't want to go to this. I don't feel like
There's a little.
I'll probably
What would you get?
Matt. Matt and Matt.
I got 50, so. I was fine with that. Average 11.
So, I know you said like,
No, whatever 11 out here.
Yeah.
I got it. You don't want like a funky 5.
We're going either way.
Like that's a lot better than I thought. Yeah, that's crazy.
as long as it's two sheets.
Oh, that's on like everyone that's like crafts.
Oh, so it's one sheet. No. It's one paper, two pieces of paper, two pieces of paper, front and back. So you have four
I had
sides.
these like crazy guys.
Two pieces.
I didn't get like any exact size.
Like, I
I got one exact
Section
number.
11 to
Other
19.
than that, everything was like a fucking.
If I were, you know how like you have to 7 to and you for sure.
I don't like
Yeah.
I don't know.
Like the conceptual ones are just fine.
Nope, it's not yet.
The lecture notes.
I need to like, yeah, either my turn's coming up or like, I need to like stay back and figure it out.
I need water.
More detail, you may discuss before the
Yeah.
What is the max?
Please, if not, I'll just make your paragraph.
Yes. Okay, let me, I'll go up this. You want me to? Okay. All right.
I only write what's on
Because my first
Okay. So there was a question about
We'll explain
okay, so this is a really bad looking sphere. This is like the worst. Okay, so pressure sorry. Pressurized sphere. Okay, and right, we say has radius, internal radius r, so we have P, R, and T, and we know that the stress in the wall is going to be biaxial, all right? And so we have like sigma equals PR over 2T, right? And let's just, if I had like a sigma x and a sigma y, okay, whichever I picked, right? Sigma x would be equal to sigma y, it would be equal to PR over 2T. Agreed? Okay. So now, right, the question is maybe what are the principal stresses? Okay, so that might be one that we could now with our new information, like with what we know from today, okay? Our principal stresses are going to be something like sigma 1, sigma 1. Actually, in the books, Hibbler uses sigma 2, okay, so whatever, but it's just because this is this is equal to the longitudinal stress in the cylindrical pressure vessels, right? So yeah, whatever. But this is sigma 2, right? So these are the principal stresses. So your question was about session 19. Okay, but we're going to take this opportunity to apply what we just learned in session 20 as well. But let's first look at the session 19 perspective. So if we're going to plot Moore's circle, and we have these principal stresses, what does it look like? You all tell me. Yes. Apu, Shlok.
I'm not sure if that's accurate, but it kind of seems like they'd be around, it's just like 1 point because it's.
Right. It's just 1 point. The 2 points are smack on top of each other. Okay? For the circle part. All right? So this is sigma, and this is in the old kind of way we did things. Not old, just like last week. All right? Just last Friday. Today's Tuesday, right? Yeah, so last Friday, okay? So if we're asked for the in-plane max shear stress, and it's just 2 points on the sigma axis, right? There's no height. There's no height, so it has to be 0, right? So the sigma, or the tau, okay, in-plane max is equal to 0. Okay, and this, when we say in plane, this would be like, if we said that this was x and y, right, this would be like the xy plane. But what do we know after what we discussed a few minutes ago? We know that there's actually this other point, sigma 3. That's equal to 0. So now we draw, oh, that's the best one I've done today. Or not today, because I was working. Anyway, the best one I've done in class. All right. So, right. So now, what do we know? We know that the absolute, if we're looking at tau absolute max, it's a different story. It's going to be sigma 2 divided by 2. Okay. Because this would be looking at either the YZ plane or the XZ plane. And we have 2 to choose from because sigma 2, it says sigma x is equal to sigma y. Did that make any sense? Is that helpful? Okay. Good. Okay. Yeah, I think every semester, well, hopefully every semester, I've kind of take a moment to talk about the spherical pressure vessel and the fact that it's just a dot. Yeah, sure. Yeah. The hardest shapes, right, are,
Yeah, crazy weekend.
like if you look at section 16, right,
and I still managed to,
those,
be confused
then,
with my life is crazy like that. I was studying
those are the hardest shapes, right? There's to figure out the torsion-based shear stress,
Oh, really?
transverse shear stress on the
I mean, it doesn't matter, I don't have my fingers there.
actual or normal stresses, right? So, you know, we obviously talked about it in class, and these are videos that we have, and these are answers in this video. Well, whatever, but those videos should hopefully be key in terms of the
Oh, you
Well, we have calculated modulus of resilience, modulus of toughness. I even had steps outlined. I'm not going to say, I'm just saying that there are steps outlined in how to calculate elastic modulus, right? Because, and part of the motivation was that one of the faculty member in our department said, our students are not graduating, or our students are graduating not knowing how to calculate the elastic modulus. So I was like, all right, well, let's emphasize it. So now everyone knows how to calculate the elastic modulus, right? Well, there are multiple parts. I think their number is, probably 10 parts.
Oh, you got one.
Well, you can a couple. You have two big questions. You have three big questions, but then yes. You can control what you can control, right? So, yeah, I'd say study the previous problems we've done, right? And have the formulas, have procedures on your sheets, and fill whatever extra space you have. Even if we don't have a problem that's identical, it's an example. I find those very helpful. And maybe we will, because maybe we will. I would love, I really want everyone to do much better on this. Okay? Because you do. Yes.
I know, there was still. Like just.
Yeah.
The first two are looking at me, like that's what he says. He's like, you're just, it's like your eye gets.
Oh, okay, good. There were people who had questions about the cylindrical pressure, the spherical pressure vessel in the group B, so I guess hopefully these will be answers.
Wait, what? Not close? I create, like, very just like punching it different.
I'm trying to get like some of these questions done.
Oh, okay. So there was a question in the group me. I guess it's a little while ago, but on session 19, number 3. Okay, and I don't know. This is I don't mind. So I guess there's session 19, question 3, and let's see. We have sigma x is equal to 10 megapascals. Sigma y is equal to 50 megapascals. And tau xy is equal to minus 10 megapascals. And the question is, what angle of rotation is necessary to have orientation with principal stresses? Okay, so in this case, when we draw more circle, ooh, that's kind of bad. Okay. We start off something like this, and it's good to set up where P is, okay? And in this case, P, 10 and 50, right? So, and then minus 10. So this P, let's say it's like somewhere around here. Okay, so P is sigma x tau xy, all right? And that was going to be 10 minus 10. Y is 50. Okay, so this is 10 here. Y is 50, and we also need to go down a minus tau. So this one down here is going to be 50, and it's going to be minus 10, so it's going to be 10. So we draw our Mohr circle through those 2 points, okay, like that. And the question is, how much do we have to rotate? Okay. And I'm going to do it this way, so to say that it's typically we're interested in counterclockwise rotation. So how much do we have to rotate to get to a situation where we have essentially, you know, to get how much do we have to rotate? To get P on the sigma axis. Okay, so to do this, it's helpful to figure out some lengths. One sigma average, right? So sigma average can always be calculated no matter what they give you for planar stress. So we have a 50 and we have a 10, right? So the distance between these two, or the average, or however you want to look at it, but the average would be 50 plus 10 divided by 2, So this comes out to be 30. So then this length right here is going to be 20. Okay, and this length right here, we already know, when I say this, you can't tell. This, the vertical length, right, this one is already given as 10. Okay, so this angle, this 2 theta p, all right, you can look at it different ways, but tangent of 2 theta p is going to be equal to 10 over 20. Okay, and if you calculate this out, this means that theta p, okay, remember we had to divide by 2, okay, is something like 13.3 degrees. So that's how you would go about figuring out how much rotation is necessary to get to an orientation with principal stresses.
So that's why. Which would use it now
Yeah, that's what everyone's telling me.
My classes are back to
Good. Thank you for asking that question.
that's the but it's
Oh yeah, did I forgot? Let me see if I am good enough to do it from my phone. I don't know if I can. that I can do simple things. I mean, I've had this one now for a while, but it's just like, it works. It was a really awesome call back in 2014.
I guess
It's kind of mistakes.
like, is it the axis that is going about,
No,
or is it the one that it's making it more stiff?
Should have like figured it out.
Okay.
Let's see.
Alright, rock on. Yeah, that definitely was the one that was the program. Yeah. Yes, Maya?
Actually, I have a question for the exam.
Okay.
This exam, so this, this is just like actually for giving back. Force with the way it's like causing energy stress.
Mm-hmm.
What determines like the steps? Like, is it the direction that you're being bended or the axis of which you're bending?
Okay, so you're talking about the load or the stress?
The stress. The
Okay.
bend.
Yeah, so if it's a bending stress, first of all, these bending stresses, they're normal stresses, right?
Right.
They're axial, right? So that means they have to be acting in
Oh, so
an axial direction.
yeah.
So in this case,
Maybe X.
it's going to be x, right? Those are going to be your options for bending stresses. The transverse shear stresses, right, in this problem, are going to be like you're seeing in the line. Okay, so the transverse shear stress. And we can draw proper. Yeah. Okay, but when we talk, well, I guess I gotta be careful. When we talk about the longitudinal stress, right, we're talking about it actually along the x-axis as well, right? So they're usually on, it would be like on the z face, right? On the z face, in the x direction.
Yeah, yeah, that's.
But it also works out that, so now we've got these, so tau zx and tau xz are.
Okay, that makes sense.
Right. So that's for the because you can say, oh, I'm drawing it in the yz plane, but it's in the yz plane, but that's really the x face.
Yeah.
Okay, because the normal x is coming out of it.
Okay,
Right.
that makes sense. And then, so for the second part, or like one of the other parts,
Yeah.
I was able to understand how we got, like this points like the sigma x and then the respective like tau x z
Yeah.
in this case.
Yeah.
But then I didn't understand like the following steps to complete the circle. Like I didn't understand why we're taking in the average and then by just dividing by sigma x and then using the average.
Okay, so the average, right? It's a little bit complicated because this thing goes just on the left side.
Yeah.
Right? So it goes on from like -0.8, right? And so this is like 38, 4, right? Something like that. Or you can use 37.5 or you can use 0, right? Either one. You can do either this average or this average. Right? We agree on that?
Yeah, I wasn't sure like how did these numbers, because I was trying to just do like, well actually yeah, I wasn't sure
Yeah,
how to get.
so those numbers come later, so you jump like that.
Okay.
Right? The sigma average, right, is coming from the coordinate here and this coordinate on the sigma on the tau axis, right? 37.5 plus 0 divided by 2. You agree with that? Plus 0.
But what if 37.5 feet like is some distance here, like doesn't really catch the angles?
So any state of stress is going to be on force. Right? always has to be on more circle, right? And so this 37.5, right, is this point, and the corresponding shear stress, which is negative, is this,
Right.
right? So when I'm calculating sigma average, I only care about where the center of the circle is. And the center of the circle is always on this axis,
Right. Yeah.
right? So if you draw a more circle and it's not on the same axis, you know that something is not right. Right, and that's because the tau xy and the minus tau xy, right? Those guys aren't going to cancel each other out. So I'm still trying to get to the point of, but do we agree that this is the average? This is the center of the circle?
I get that the average being center of the circle, but I'm not understanding how it was just impacted by.
Oh, because this line goes all the way down to here,
Right.
right? And what's the sigma? It's 0.
Okay.
So the average is 37.5 plus 0. Then divided by 2. I just didn't write it. Because we're interested in this average, we're interested in this. Right? It's like saying, hey, I've got 2 points on a circle. And I can move, around the circle, right? But the center of the circle is always the same.
Okay.
So if I want to know where the center of the circle is, as long as I have x components of 2 points, I can calculate where the center is.
Okay.
Or at least the x component.
Because in this certain,
Yeah.
like the in-plane stresses in this case are 37.5 and then 0 in the other direction. So that's why I really wish we did 0.
That's correct.
Okay.
That's
Okay.
correct.
Yeah. Okay.
That's right. Yes, thank you. So this is 0, right? Sigma y is 0.
Okay. Okay, that makes sense. Okay.
So now we got that.
Okay.
So now what we need to do is we need to figure out the radius, right? And so we can figure that out by looking at really this point or this point, whichever one, and we know where the center is, right?
Yeah.
And so we use Pythagorean theorem,
Okay. I see.
right? Then that's the radius. Then once we know the radius, then we can say, oh, from the center, if I just go to the right, I just add the radius, and from the center, if I go to the left, I just subtract the radius. And that's how we come up with these 2 points, which correspond to the in-plane principal stresses.
Okay. Makes sense.
Does that make sense? Okay, good. Thanks, Maya. Yes. Okay. Yes. Sure.
I know that this is a much easier way
Right.
of doing that,
Right.
but for this, it's still correct because we don't use the A times the other.
So, what's happened is we've gone off of the neutral axis, right? And we didn't compensate for it. You can do it this way,
Yeah.
right? But then you have to use the parallel axis theorem off of those kind of 4 individual pieces.
If I were to do it this way, would it just be?
If I remember doing this correctly, I'm pretty sure.
Yeah.
They're not wrong, so-
Well, no, it's a square, right? It's yes. Well, it's actually in this case it's whoa, everyththing's moving so fast. It's actually
Sorry.
it's actually cube. So it's you're carrying because we're doing the
I mean, we're interested in how we use.
No, I'm
saying
here.
the exams or sessions on the session.
My transition here, so I took pushes
So
to
it's actually
my
gonna be
trans.
which plane stress and more stress.
And if this also.
Because it's a
It'd be stuff for a Z, it would be the subject is there.
That's right.
It's just, you know, plug
Oh.
in.
Right? So, but it's because it's offset, it's not even cubed divided by 2, right? It's like a offset, so it's like a, whatever this gap is, plus cube, and it's not even that. So you had, that's why you have to do like half of this plus B, I guess. Whatever that, or not B, but whatever that gap, half that gap is. So it's just very tedious.
Yeah, I'll go when you want.
But thank you for asking, that's right. That's the right idea.
It's like one today. Right, I'm like, okay, but I have this piece. Okay. And part, so that's what we're at.
What I might do is, I might try to get a bank account and just complete all of the homework by like next week. Just so that like I know all the topics. And then just study for the next like 3 weeks. Actually, every time so I'm still at 70 pages. That was my strength. Homework so far.
Naturally, we're now, this time.
And then for the final, the weekend before, my down.
Yes,
I don't even tell them. That's like me out being crazy. What are we doing now? Yeah, that must have been wrong. Was there?
Mine was some like.
Like, did you guys just have textbook problems? We never. You can go on the, like, the person was down.
I think it's sexist.
So that is.
Yeah. Okay. No, because I'm still ready to get a chance.
Yeah, I would.
There's a couple things that are history of for
Class a teacher for practice problems.
No, it's not.
So what's the practice
Like, the
problem?
answer was the same. Oh, it's the same. I thought it was like in there.
And then the exams were like, what is it? I remember the first exam. How did you even do it?
Barely.
Just not even 4%. So you just got it. The only counter one.
I was wrong. I was like,
Shout yourself. I'm almost out of it. What'd you say? I'm almost out of it.
Oh, wait. That is exam. Right, that's, so where's
You probably got a positive. Do you wanna know my answer?
No, I have my answer, but I already did it. When I redo it, I don't know how I got a positive.
Yeah. See, it is correct.
if you look at number 2, it's like
You were all this over here. I don't even, and yeah, this here. All this, do not need that. Just do the same thing you did for 15, that's it. And then, next minus one.
We're just max.
Yeah.
It looks
No, next course.
My back for so long.
Yeah.
it's
This way.
So wait, so
Like, you might want to make a
minus
about that.
Then it's like not
The worst part was
I always see this information.
I was like,
Well, I always think Canvas is the two.
Wow.
like all the new tracks.
So just
I only have one.
Yeah, I
To be honest, I prefer
Passport.
Yeah.
I know you were like,
you told me.
remember right? No, right after the physics exam, you were like, bro, I don't know.
I was like, that's too easy.
Like which,
I doubt it, because
They're like, wait, what is she doing?
we're in a
question.
incorrect.
Oh, okay, well,
That was right.
I was like,
this is fun.
it was a.
You know,
I didn't know that.
when I was in undergrad, there was a guy
This-
that I loved.
this one is,
to work
it
with.
causes it to like,
I mean, there's
Yeah,
multiple
further
ones.
side.
Right.
So one of the guys next to me,
Yeah.
That means.
how you feel
Yeah,
about
it's
the
the same grades as exams, but we did like different parts.
I think
So I think we
it's.
did that when we were taking. That's opportunity right there.
One person, two person.
That's right, that's right. So like, we did about the same grades,
Oh, yeah,
but.
slice.
But their exams were messed up. Like,
Yeah, we're slicing the same.
Canvas, and what you pick next, you can go back.
That's
Like, exams, like.
Like,
And you were
Like this.
yeah, like
Um,
here, if I was
yeah, no, I
pushing it
just
this
have my
way,
exams.
like
Yeah.
it causes.
To be honest, I guess
like,
how-
this
I
side
feel like
is in compression and this side is in
I'm gonna take it
tension.
next semester.
We ended up being a.
Just through the middle.
Whoa.
Like
Yeah,
that.
and a professor, so we.
Cutting here.
It's at this 4 hour
Both sides
lecture.
of this.
Well, so you get
Like, yeah, if this side's.
Oh, that's awesome.
Those are a month. I'm already taking thermals now. I'm doing a job, which
I
honestly,
have no
I'm like,
idea.
So you take a lot of time to courses.
Good for him.
I mean, I'm sure I can work on my own case. It's like the same thing. We'll see. There's a lot of factors that need to
Wait,
Oh, yeah.
why
What?
are we leaving it in?
That's crazy. He's basically.
I thought they're the same thing. One of them is static.
The same thing.
No, like what's the difference between like this
If I
end
want,
and
I'm
this? They're the same
Yeah.
thing.
No.
No?
Thing is, my family.
Oh, you're saying this
Yeah.
one's going this way.
More than
That this, the M goes this way and T goes this way. But in theory, they're the same thing.
Yeah, okay, yeah.
Now back to previous session.
Sorry, what did you say?
I'm gonna be honest, I'm reviewing some old stuff.
That's great.
Yeah, no,
If you have any questions, let me know.
Thank you so much.
Make sure you don't wait for that new answers to really old stuff. Obviously, we that. We get at least now, we get zeros.
I actually did do that for one of them a while.
Oh, wow, okay, well.
But like if you already have the answer,
You have 17 actually, it's the latest one.
No, it's
Friends
just-
keeps the highest.
It does keep the highest now?
score, yeah.
That's what it says.
If I
I've
find
had
it,
people not.
I can try.
No, don't try, please don't try.
For like one of today's.
For one of today? Oh, yes, for today. I'm talking about if we go back and do one of the later ones.
Oh, then you get like the late
We
penalty.
get the later one.
I did that.
You get the late penalty, so you get like a penalty, but your high score.
Yeah.
Maybe.
That's
You still get your high score.
I don't know.
If I find out, I'll email you just to let you know.
Maybe
Okay.
someone's trying to
There
play
is-
you, Professor. I don't know about that.
Really?
That
I
sounds
thought-
suspicious.
Is it sus?
Yeah. I think you're getting played, sir.
The only reason I know what sus is. Well, I have a daughter who's 13.
Oh, there you go.
That's
like the same.
Well, you know, during the pandemic, Among Us became really popular, right?
We would
Yeah,
play
that's
it in class, and one time our teacher
Oh,
did it in
they're
high
so
school.
smart.
It was so funny.
Instead of doing like.
Because I don't know how he found the
and
code.
saying,
He just hopped in and said, "You guys
Let's
shouldn't be
look
here. Everyone here
at-
is getting like a zero for today."
What?
Luckily,
Oh,
my
yeah.
name was up.
Sigma,
He couldn't
Sigma.
find me.
Tax,
But there was
tax,
like
whatever.
John
They say,
Donovan
look at the
got
contributions
caught.
from
Okay.
here.
Everyone went by their real name. It was so funny.
I played Among Us.
It's just so much simpler, right?
Yeah.
They are okay, let's find.
I don't think so. I think it popularized.
I think it was
They're just saying,
popularized
look
by
at
that,
each
but
of
like people were
the
saying
courses.
it before.
People were saying like
I
that's
would
sus,
say,
but they
look
weren't.
at it and see
They
what
weren't
makes
connected.
them
Every time someone says
what makes
sus
it
after
happen.
Among Us, I'm like Among Us.
Okay, yeah.
That game fell off so much. It used to be
Well,
so
it
much.
was,
Causes
wasn't it around for a while and then not played, and then the pandemic hit and then everyone started playing it?
I feel like that happened with a lot.
But you know one of the reasons people stopped playing it? They removed a feature of the chat because people were getting bullied on the app.
Oh.
Why did people probably were getting bullied on the
No, some of the bullying it's shown was like people just jokingly framing other people for being the imposter.
Oh,
They are
you
the
still need to
imposter.
have a degree of sensitivity, alright?
Yeah.
Well,
Yeah.
no, I agree that is true. But what I'm saying is like some and like there was a
You're being recorded, Sean.
Yeah.
One
Before we dig ourselves into a hole.
If you want to get a job in the future.
One time I got accused when all I did was pretend I wasn't the imposter, right? So I started blaming it on this other kid saying I saw him then. I kept saying I saw him then, and he got mad at me when I was just trying to play the game. You know, the whole point of the game is to trick people into thinking.
Cool. And then.
So we go over something from session 12.
Okay, it's a while ago.
Cool.
It's like a lifetime ago.
Yes.
I'm just keeping you on your toes. I want to make sure it's fresh in your mind.
Fresh in my mind. Oh, thank you. Okay.
Let me pull it up real quick.
Yeah.
Because Shloka was doing the problem, I was like, I actually should go over that. So.
You fucking shit.
Send me two tours. Does this help? That's true.
Very true. No, it's this one too.
You're saying why there's no better moment when he like lived in this way?
Yeah. So
That's right.
this question was. So this is it's more of like I guess because that is a question. Yeah, this is Q1.
Yeah, I can get in the negative with
Right?
Uh-huh.
It tosses it to bed this way. So there would be like
So
this
this
way.
question is,
That's what you're saying.
but what is the maximum?
Because it's on the central axis, it's zero.
Okay.
Like if point A was like at the top here, then it would be in compression. And if point A was at the bottom here, it's in tension. But I don't know if you can tell on the 3D, it's like literally like smack here. So it's not in tension or compression. It's its own unit. Yeah.
Maybe I know.
Great. Oh my gosh, I'm taking also my makeup math this You
and it was a freebie.
Yeah, maybe it never came out.
Yo.
It's
Sorry.
in general.
I had no choice.
Oh yeah.
Mama, you got that.
Yeah, like, you forgot to give it, so it was this past
That was
one.
your fault.
Yeah. And then we have another one this Wednesday, that I'm missing. So I said, oh, I'm missing that, like, do I need to make it up, whatever, he's like, yeah, do my office hours work.
Okay,
I can't come Wednesday.
so this is the problem, right?
Correct. Yes.
Alright, well, we're trying to figure out what is the maximum bending moment along the Okay. And first, right, for any of these problems, we do external equilibrium, correct? We're good with that?
Yeah.
Okay. Now, when we do that equilibrium externally, right, we know that there is no bending moment, right, at these ends, because those are roller and pin boundary conditions, correct? Okay, so if we're asking for maximum bending moment, it has to be happening.
Yeah, but this is somewhere else.
Okay, so there are a couple ways to go about doing this, right? One is straight up equilibrium. Okay, and so we take a slice, and then we look at the result, right? The other way is to use the interval method, right? To do that, right? So yeah, so there were a bunch of thoughts, I guess, like script this is not true. Okay, so now if we go about and look at this problem, okay, with internal equilibrium. Okay. First we did external equilibrium. Sorry, first we do external equilibrium, right? And then we can write out equations for internal equilibrium. Okay. And we start when we're doing internal equilibrium, right? We have kind of two regions we can take a look at, right? We can look at this. We can look at this region, right? And we can look at this region. Okay, so when we're doing internal equilibrium, right? If we're going from the right, there is no W naught. Okay, so that's kind of, I mean, not boring, right? Well, maybe it is a little bit less interesting, right? But we use the correct convention for the V and the M. Does that make sense? Yes.
So when I was doing it, I did it from the other side with R1.
Yeah, so we're going to do that in a second.
Okay, I guess.
Right? No, it's okay. We're getting there, right? So this is for the right side. From coming from the left, we got to make sure that V is going down and M is coming this way, correct?
Yeah, but if M is going that way, wouldn't like WO be a positive, cause a positive moment and R1 cause a negative because it's countering moment?
So the way there are multiple ways to write it out, okay? And I did jump a little bit here, okay? But sometimes if I'm not sure, right, I'll write out everything equals 0, right? So if I write everything equals 0, is M a positive or a negative?
Positive?
Yeah, M's positive, right? And the other thing that's important is we have to determine from where, right, we're doing this moment. So in this case, right, there's no V in here, so that means we're doing the moment at this point, right? So M is positive, and so is the W naught X,
Also, you add it. Oh, okay.
right? So it would be M plus W naught X times X over 2, okay? And as we change the length of this region, it moves where W naught X is being applied, right? Okay, until and then, once you get to this region, once it's no longer there, then it would just be halfway across. But it's moving, right? And that's reflected by the fact that we have X over 2, right? X over 2 is a variable describing where we are that we're doing our cut, okay? And then, yes, R1 acting at a distance X from here is going to be contributing a negative moment. No, you're not. Why? Don't say that. Why?
I don't know how I got that. I was.
Yeah. Okay. So is that
Yeah.
helpful?
Yeah, that's perfect. Thank you.
Okay. So yes, did I cheat by going to the slide? Yes, I did. Right.
It's okay.
But it's that way we know we're correct.
At least your slides actually have your own handwriting on them, like other professors.
No, I mean, look. Who am I to judge another, right? I've used many diagrams from other people. In this course, though, this time I made a concerted effort to have my own drawings, but a lot of that is because we're going and putting it online, and we want to attribute people, right? So a lot of the stuff is from Hitler, or when we put the sources there, right? So it's hand drawn, and then we also have stuff from Wikimedia Commons. So yeah, I think it's good to have both.
Thank you.
Be sure. Yes.
I love Jeff. That's your answer. Very fast.
What is that?
That's
That's what you're doing. What is
Zero
it?
is a thing where this is you weigh stress guy, 3 and stress and
Okay, so if it's an X there.
So
If it's added to the X.
Your son being
This
the
is
crazy.
and it's doing something like that, then
Oh, because it pushes into the top or into the bottom. As in, it's not climbing. Right, it's not consistent with space, but at any given point, like over the whole A, that term isn't consistent. It's like goes here and gets less and more. But at A, you can add up the value of one and the value of the other. So what's normal to A at.
yes,
Like,
yes.
yeah. I'm not gonna do you. What's Friday?
Oh, no, I'm
On Monday.
I just said some sessions.
Oh, word?
If you're going on test and
Yeah. No, I just figured it'd be some room.
Would you shear?
Because they basically they don't average. That's usually like the other ones are like weighted, like it doesn't. I think usually that's what they do with like classes where
Okay.
it's easier to say.
Good. Good guys, good. Nice, right?
Actually, for deep last year, we'll be doing make it up, I think, but then there ended up not being a that week.
Thank you.
Okay, see you on Friday. We'll have our class reunion. Yes.
Is it fun when we have a test stand, like we see what we've seen here before?
Well, you saw them the same one.
That's true.
I'm still kind of like yeah. Okay, so how? Okay, good. So you
Yeah.
Okay,
I'm
good.
Yeah.
okay. And good. See, I'm here. Rock on. Thanks for coming, folks. Sorry.
Right.
Hello.
Can you tell me the equation for I for a circle?
Sure. It's I over 4, C to the 4. There's a typo.
I don't know. I was like scrolling through and it confused me. It says I over
Yeah. So I put a note. Actually, are those from recent notes?
No, this is session 16.
Section 16, yeah, it was wrong. It was wrong.
Okay.
Yeah, it was wrong. Yeah, in fact, for session 19, or session 20, which is today's, in the YouTube comments, or not comments, the YouTube description, I said, oh, this is wrong. I need to be, not that. I just love pie so much. I just threw it in a little more time. Yes?
Thanksgiving is the best time.
Like just like the
I just really here. I hate all these. I feel like it's all about like I go to like Stanford Party and like I don't like turkey, I don't like green onions, I don't like sauce, I don't like
What about the pie?
I don't like cookie.
You're right.
Yeah. I mean, I've never had it, so I'm not gonna hate it.
All right, so thanks guys for coming to class. It's about time to wrap it up. Really get some sleep Thursday night, okay? That's my suggestion.
Can I sleep Friday in class instead?
If you have some way to like magically levitate your pencil with your mind as you're sleeping there, I think that's an interesting strategy.
I do as well, right?
Okay.
I'm just gonna do your test. I don't think you want me taking your test for you.
Alright, so no, get some sleep, alright? Get some sleep Thursday night. I'm hypocritical, I didn't get much sleep last night, but this is the type of exam where you want to be able to think clearly.
These are spooky times. These are very scary times. It's okay, but we just gotta get through this. In the summer, it's gonna be